Example 2. Again, we are looking to utilize different strategies here. So we need to evaluate the following. The integral of e to the square root of x dx, like so. Square root of x is in the exponent. The solution. All right. Without much debate or hesitation, we're going to substitute square root of x with u, and therefore u squared equals x, and therefore 2u du equals dx. Clear? So now the integral of e to the square root of x dx. Pull out the 2, and it becomes the integral of u e to the u du, and this is a case where we have transcendental u, which is really a simple function, a linear function, and e to the u, which is transcendental. So in this case, we'll use integration by parts. So we'll choose what? We'll choose integration by part. We'll choose u to be u. I like to say that. Let's choose u to equal u. And then dv equals e to the u du. And of course, du equals du. I'm sorry, this is silly, but v equals e to the u. And now we're going to say that our integral will be u times v, so it will be u e to the u minus v du. So it will be minus the integral of e to the u du, and of course it's going to be u e to the u minus e to the u, or u minus 1 times e to the u, and finally, having in mind plus c, of course, u is the square root of x, so we have, by the way, we have 2 in front of everything. Forgot the 2. So let's multiply everything by 2. And now we will have 2. U is square root of x, so square root of x minus 1 e to the square root of x plus c. So this was really a quick one, isn't it? Okay, so a short one deserves a long one. The next one probably going to take us longer. Actually, no. The next one is no doubt difficult either. Example 3. We need to evaluate the integral numerator is x minus 1. The denominator, x squared minus 1. The denominator is x cubed minus 3x squared minus 10x dx. Let's look at the denominator. Of course, this is a rational function. The degree of the numerator is less than the degree of the denominator, so this is a proper rational function. We don't have to apply long division. And furthermore, we see that we have a common factor, which is x, and the cubic is reduced to quadratic. And this is factored nicely, because negative 10 is negative 5 times positive 2. So we have x times x minus 5 times x plus 2. So we end up having 3 linear factors. In this case, it's a piece of cake, isn't it? And we're going to say that x squared minus 1 over x cubed minus 3x squared minus 10x, the linear factors are x and are x minus 5 and x plus 2. So you want to go A1, A2, or A3, or ABC? ABC, ABC. Okay, so ABC, in this case, we don't have to go through solving a system, as you see, because we have 3 distinct linear factors. You may remember, or you may note, that I said that in this case, there is a shortcut. Let's first write it out. Since A is divided by x, we're going to multiply A by x minus 5 and x plus 2, B by x and x plus 2, and C by x and x minus 5. Okay? And now we don't need to do much because we can let x equal 0. In this case, if x equals 0, then negative 1 on the left equals, so let's see, these two disappear, and here we have negative 10a. So from here you get a equals 1/10. If we let x equals 5, we're going to cause these two terms, the a term and the c term, to disappear. And of course, here we have 24 when x equals 5. And let's see, we have 5 times 7, that's 35, so 35b. So therefore, b equals 24 over 35. And we don't have a common factor here, so we leave it at that. And we let x equals negative 2. And the a term disappear, the b term disappear. What's left is the c term, where for negative 2 we have 4 minus 1. On the left we have 3. On the right we have negative 7 times negative 2. That will be positive 14. So 3 equals 14c. Therefore c equals 3 over 14. Yeah. So the integral equals to what? Let's see. A, 1/10. So we have 1/10 integral of dx over x. B, 24 over 35. Integral of dx over x minus 5. And 3 over 14, integral of dx over x plus 2. Okay? So, 1/10 natural log of x, 24 over 35, natural log of x minus 5, 3 over 14, natural log of x plus 2, plus c.